Okay, welcome back everybody. My name's Glen Robinson and I work for Amazon as a solutions architect. A solutions architect at Amazon works with our customers. In fact, I work with some people in the room here today. And I offer best practice guidance on how to build your solutions on top of AWS. But today I'm actually going to talk about cost optimization. The first thing to think about in terms of cost optimization in the cloud is one of its core components, which is the elastic capacity, the elastic nature of the cloud. Elasticity is a fundamental property of the cloud that drives many of its economic benefits. What does that really mean? Well, simply, when you turn off your cloud resources, you actually stop paying for them. Here's a really simple example. Here's my website. 6 o'clock in the morning, no one's looking at my website, unfortunately. I've got my load balancer, and I've got very minimal infrastructure just to keep my site alive at night. 10 in the morning, thankfully, some people are looking at my website, so I start dynamically scaling out my web server infrastructure to meet that demand. And when that traffic dies off again, I reduce the amount of infrastructure and stop paying for it straight away. Here's a very obvious utilization graph you can see here. Across the day, you can see my utilization increases throughout the day, peaks, and goes back down again at the end of the day. So when I'm planning, if I was buying servers in a traditional world, I'd have to buy infrastructure to satisfy not only the peaks, but also some overhead to make sure that I'm always able to satisfy my users' requests. Of course, in the cloud, it's a whole different world. Here I can make sure that I provision enough infrastructure, so this is 50% of my fleet of web servers. I can double the amount of infrastructure in the morning to satisfy those requests, and I can halve it again in the afternoon. And that effectively means in this simple scenario that I'm making 25% cost savings. Here's an architectural diagram of my website solution. You can see here I've got my website domain name. That's in Route 53, which is Amazon's DNS service. That's pointing at my Elastic Load Balancer, which is distributing the incoming requests over my auto-scaled web fleet, which then pass on those requests to my auto-scaled application servers. And behind the scenes, I'm using a MySQL relational database service in the HA configuration, so I've got a slave and an alternate availability zone. And I've got my static content stored in Amazon S3. And then front in S3 with Amazon CloudFront, which is our CDN service. Of course, at night time, again, when people stop looking at my website, I scale down my infrastructure and I stop paying for it. So there's different types of auto-scaling you can do. You can scale by schedule. So if you've got more predictable workloads, then you can specify a time and a date, and you can scale up your infrastructure so you're ready for that demand when it comes. You can also scale by policy, so you can track metrics using things like Amazon CloudWatch, so you can track your CPU and your network I/O. And depending on the levels of utilization you're seeing, you can add servers to the fleet and reduce servers to that fleet. There's two different types of scaling you can do. So horizontal, which we've talked about, which is where you scale out your fleet of servers and scale them back down again. Also vertical scaling, when you can increase the amount of horsepower for a particular server and then scale it back down again. Here's another simple example. This is over a month, so a much longer time frame. And again, the amount of web servers in my fleet up the left-hand side. You can see for a few days of that month, the utilization is massively increased. So again, in a traditional world, to satisfy that load, I'd have to make sure I provisioned enough infrastructure to satisfy that peak, but I'd be running it all month long and paying for it all month long. Obviously, in the cloud, I can provision infrastructure just for that set time, and the rest of the month, I'm just running a minimal fleet to serve that utilization. And in this simple scenario, I'm making a 75% cost saving. So with the vertical scaling, in my website scenario, I could choose to scale up my relational database service. So most of the month where you're seeing minimal utilization, I'd run a small instance type. With a reboot of my server, I can place it onto a larger instance type for a few days. And at the end of that high utilization period, I can then scale back down again. And again, I can do horizontal scaling with my Elastic MapReduce clusters, for example. So if I'm processing information at the end of a month, I can scale up my cluster, process that data more efficiently and faster, and scale it back down when I'm done. Reserved instances. So a reserved instance is the ability to pay us an upfront charge for a reduced hourly cost for EC2. And we have 3 reserved instance types, 2 of which are new. we have a light utilization reserved instance type. So anywhere between 15 and 40% utilization, that's going to lower your costs up to 33%. These sorts of things are the infrequently used infrastructure, things like disaster recovery solutions, periodic processing. We have a medium utilization reserved instance type. So this is aimed anywhere between 41 and 79% utilization and can lower costs up to 49%. This is more the example I gave earlier with the web applications, heavy processing types. And for those of you familiar with reserved instances before, this is the old RI that we've always had. We have a heavy utilization reserved instance. So this is for any of your workloads that are running greater than 80% of the time. So this is your baseline infrastructure. Your databases and your web servers are always on to make sure your site, your solution's up and running. And here you can see that depicted on this graph. So you can see the blue line here is an on-demand instance and the price. You see there's no upfront charge, so it starts at 0, it gradually increases, and you have light, medium, and heavy utilization. So you can see here, the on-demand is efficient up to about 15% utilization, and you always want to stay below the line to make sure you're cost optimal. So then the purple line is our light utilization reserved instance at 40%. The green one kicks in, that's the medium utilization, and then the heavy utilization for 80% and upwards. But of course, your solution is going to be made up of different types of RIs. So you've got your baseline infrastructure running 24/7 at the bottom here. And of course, you're going to start using a mixture of medium and light utilization RIs for your different workloads. And on top, you're still going to be using on-demand for your unpredicted workloads, the traffic that you can't see coming or you can't normally account for that happens infrequently. And all this information has just been written up and published on our website in a white paper that was published in December 2011. So we've got many instance types you can choose from as well. This is just a small selection here, ranging from our small, which is the original instance type that we launched originally, ranging up to the beast that Matt talked about earlier, our quadruple extra large cluster compute instance type. You can see the different prices here. A good example here is this high memory. You can see that the cost just doubles every time. So a double is twice the price and twice the size, twice the horsepower of an extra large, and a quadruple 4 times. So when choosing your instances, which ones to use, which ones to go for? So we offer some basic guidelines, some basic recommendations to make the right decisions. The most important thing is choosing whether it's 32-bit or 64-bit. After that, we suggest you pick the closest number of virtual cores and also go for a more granular option so you can distribute these servers over multiple availability zones to create a highly durable solution. But the real key here to remember is that this infrastructure is disposable. You don't have to spend a lot of time up front making a correct decision. You can fail fast and quickly change this. If you get it wrong, if you under-provision an infrastructure or over-provision infrastructure, if it's an EBS-backed instance, you can reboot, you can re-provision onto a different instance type, a larger instance or a smaller instance, start it up again, and off you go. Your state's been preserved on that instance, and you're up and running. And we also recommend that our customers do this all the time, actively going forward. So track your own metrics. You can use Amazon CloudWatch. You can track either CloudWatch metrics or indeed your own custom metrics. Put them into Amazon CloudWatch. You can set alarms and notifications. So you will actively be informed. You will know when your servers are or aren't being used, and you can change the instance type and make that cost saving straight away. Spot instances. Excuse me. So, as Matt said earlier, this is the ability to bid for instances on our spot market. So, spot instances are the unused EC2 capacity available in our data centers. So, when that capacity becomes available, we sell that on a discounted rate. You can bid on those instances and use them for that discounted rate. Sounds great, right? So, what's the drawback? Well, if we need this resource back, and we need to put it back in the on-demand pool, then we'll reclaim it. We'll take that instance away from you, and we'll add it back into the pool. So we're making decisions about what type of applications to run on spot. So it must be a very considered decision. We'll go through some examples now. So in the console, you can see up to 3 months' worth of spot pricing history, and this is done by availability zone. And you can also make spot requests on our console. You can put in your bid price and wait until that gets provisioned. So different bidding strategies to use when buying spot instances. Here's one. Optimize for cost. So when would you use this? Well, this is when an application has been designed purely with cost in mind. So an example of this might be my website, offer a premium subscription-only service to my customers. I know how much revenue I'm going to generate from this, and therefore I know how much infrastructure I can run to still make a profit on that solution. But I might also offer a free service to my customers. So for these guys, I want the rock bottom price for my infrastructure, and I still need to be able to be profitable. So an example here would be, I've got a website, I'm providing this free service, a function to my customers. I decide how much I can spend on the infrastructure to run this service, and that's my spot bid. At times, of course, the spot market, the spot price will go above my bid, and Amazon takes those instances back. But for me, that's fine, because this is a free application. If I'm not serving those user requests instantly, I'll store them, I'll wait until I've got compute capacity, and I'll run them later and give them back the response that they requested. I just keep doing this over time, because I know eventually the spot price is going to come back down, and I'm going to be able to process that request from my users. Another strategy is the price history momentum. So this is where customers don't want to be interrupted as often. So what they do is they monitor the spot price. They take averages over the last hour, and they put a spot bid in about 10% higher than the last hour's average. And generally what this means is that they will be tracking the spot price just above, but there's very rare occasions where they'll be below the spot price. This means, of course, again, the infrastructure will be pulled away. What it does mean is that they stand a greater chance for having that infrastructure for longer before we take it back off them. Of course, if you look at where the on-demand price is on this graph, that's the difference, and that's the amount of money they're saving whilst running on spot. Another option is to discount over on-demand. So this is where our customers bid around about the on-demand price, but they flip and use on-demand instances if they need to. So it's another simple example of when someone's bid. The yellow line is the on-demand price of those instances, and all their requests have been fulfilled, and they're running infrastructure, which is fine. Other times, though, when the spot price goes above the on-demand price, they'll stop, they'll switch to an on-demand instance from the spot, and then when the price goes back down again, they switch back to a spot instance and run on that again. So they're jumping between on-demand and spot. Of course, during this time, they're making large savings on the spot market, and at other times, they're just running in on-demand. So on average, they're still making substantial savings. Another example, with a company called Litmus on AWS, they actually bid to minimize interruptions. They actually bid in above the on-demand price. So here's the on-demand price. They make a bid above that, because they're hoping that the spot price will never go above and beyond the on-demand price, meaning that they, for the most part, the top of the green line here is the on-demand price. For the most part, they're running below it, and they're making savings. There's a small chance every now and then that the price will go above the on-demand price, but on average, it still evens out, and it still means that they're going to be making huge savings. In their case, it's 57%. There's some interesting analytics that we did internally. This shows spot bid distribution, so 100% being the on-demand price of an instance. So you can see that the most common bid is on-demand or slightly higher. So people are bidding just above on-demand price. There's quite a nice distribution to the left of people bidding below the on-demand price to get cheaper instances when they can. Also, you can see here what's interesting is there's still quite a high percentage of people, over 6%, that are bidding twice the price of the on-demand to ensure that they've always got that capacity. And again, they're hoping that over the average, that they're still going to be saving money. For more information on Spot, you can go to our website. And there's other complementary services that Amazon offers as well to help you save money. Here's one simple example. If you wanted a load balancer, you can have your own EC2 instance. You can run your own piece of software on that. Or as an alternative, you can run an elastic load balancer. If you look at the price difference, we've assumed this is a small instance type, so it's 9.5 cents an hour. An elastic load balancer costs 2.8 cents an hour. Another example would be SQS. So SQS, if you're going to run your own message queue service on a small instance, would cost 9.5 cents an hour. The SQS costs 1 cent per 10,000 requests. So making use of these services could be very cost efficient for you. Obviously, the software on EC2, the main pro there is you can customize this. If you've got very specific requirements, you can customize it to your particular needs. Obviously, you need to run an instance that's going to be slightly more expensive than using a service. It will be a single point of failure if it's not designed to run in a distributed environment. Therefore, it could be limited to one single availability zone. And you've got the operational overhead to manage that instance. Of course, services are designed to be pay-as-you-go, scalable, highly available, and highly performant. So today we've discussed elastic capacity, the ability to grow and shrink your environment, to follow your utilization to save money, the different reserved instance types and when best to use those, the spot instance market and spot bidding strategies and which ones to use when, different instance types, and to make sure that you're making informed decisions about when select an instance type, but don't worry about changing that because this is disposable infrastructure. And also a set of complementary services that are going to enable you to save money. If you want to work out how your solution would fit into the cloud and how much it would cost, we've got a calculator online. And you can go there, you can select the region that you want to deploy into, you can select the services you wish to use and how much of them you want to use, and it will tell you how much a month that will cost. That just leaves me to say a very big thank you, and for any questions, I'll be at the bar. So thanks very much, and hand back to Matt.
Okay. Right. So thank you, everybody. We are rounding out with the last session of the day. I'm going to talk a little bit about deploying flexible enterprise IT solutions. So this is something we've seen a big uptick in on AWS in the last probably 6 to 12 months. So I thought it would be worth talking a little bit about how we're approaching it at Amazon. I'm going to talk a little bit about some of the new features that we've deployed over the past couple of months to really help enterprises take advantage of some of the elasticity, some of the cost efficiencies of running up on AWS. So a lot of customers sort of start thinking about AWS from a cost saving. That's really the sizzle, if you like. But the steak, the thing that keeps people coming back for more, is really speed and agility. The speed and agility that the cloud offers to customers, whether they're a small startup, two people in a bedroom, or whether they're a large multi-team organization, large enterprise. And those guys need it just as much as the startups do. And the goal of AWS is really to allow customers to take their initial idea and move that idea through to a product to ship it to your internal or external customers as quickly as possible. The problem is that there's just more of this heavy lifting associated in moving this idea to this product. So this is this infrastructure friction of working in a traditionally provisioned environment. And when we started looking at using these sort of tools inside Amazon, we noticed that about 70% of our time in just moving from our idea to getting a product into customers' hands, 70% of that time was spent on this undifferentiated work. Just the provisioning, the capacity planning, and all the other stuff that goes along with managing infrastructure at pretty much any scale. What we saw when we started to take this sort of service-oriented, web service-oriented, infrastructure building block approach was that totally inverted. So we went from spending 70% of our time working on worrying about infrastructure and all the rest of it, to 70% of our time just building out products that we hoped our customers were going to love, supporting our business, growing our business, and growing our customer base. And we did that by moving to these infrastructure services. And at AWS, what we want to do is remove that overhead as much as possible, and to a point where you are as comfortable as possible. So as Glenn was mentioning, we want to give you the flexibility where if you've got specific requirements for load balancing, there's a platform and there's an EC2 instance there that you can run that on. But if you are happy to run on the Elastic Load Balancer, take advantage of this rich ecosystem of products that we're developing, then we can reduce that friction. And I think some of the tools we've talked about today, such as DynamoDB, Elastic MapReduce, and Simple Workflow, really talk to moving ideas and products as close together as we can possibly get, to remove this friction and turn IT from something which was initially designed to help us build out businesses and serve customers, but which has typically come to define the constraints that we find in business, turning those constraints into things that can accelerate businesses, moving, as I say, from these ideas to these products. So our goal really at AWS, and something that we hear a lot of feedback from, and everything we do is driven by feedback from our customers, so please feel free to send it to us, as you all do. But our goal is to try and make these tools easier to use, trying to make them easier to connect to, and this is something that enterprises get a lot of value from, and make them easier to integrate into existing systems. So we want to try and do all of these three things, and in particular, over the past 6 months, you've probably noticed us having something of a push to address these issues for enterprise customers. Enterprises that want that same agility and speed, they want to be able to use IT not as just a cost sink, but to be able to fuel the innovation within their business. So I was going to just outline for you as we close out today, just 5 things, 5 new services which we've rolled out specifically geared towards making it easier for enterprise customers to consume, integrate, and connect to some of the Elastic infrastructure that we make available on the AWS platform. So the first thing I'm going to talk about is something we call VPC Everywhere. So for those of you that are not familiar, VPC is our virtual private cloud. This is a specific set of services which allow you full network customization. So allow you to run in a network-isolated environment on the EC2 platform. So it's all the same features that you're familiar with EC2, elasticity, scale, availability, integration, but with some extra additional bells and whistles specifically around making the networking as controllable as possible. So you get full network control. With VPC, you can create public and private subnets. You can customize those. You can bring your own IP addressing. You can bring your own subnets and all the rest of it. And you can also extend your existing virtual private network up into EC2. So the goal here is to allow EC2 to just be additional resources on an existing corporate network and to make that as easy as possible to administer and as easy as possible to secure. So you can start to build out features like this. So you may choose to use VPC just in a purely public subnet fashion. And you can deploy your instances inside a public subnet where you have full control over network access controls, both inbound and outbound, in addition to the existing security groups that exist on the EC2 instances. So you can build out a public subnet. A lot of customers use these network access control lists to build out a public-private subnet mix. So a certain amount is deployed in a public-facing website, but they'll have another tier which has different network requirements, has maybe a different network topology design, and they'll use the security groups, access control lists, and a private subnet in which to host those. Customers are also using this approach to extend their existing data centers. So having a collection of resources, a collection of compute, storage on-premise, and extending that by extending their existing IPsec VPN and taking their existing identity and access management policies all the way up into an elastic, network-controlled, isolated environment up onto EC2. And likewise, you don't even have to run the public bit. So if you want to just create new private subnets, you can just do that quite happily, bring your own existing IP address space, and deploy that up onto EC2. So you get the benefits of elasticity, get the benefits of being able to bend and flex your environment, but you can still hook into your existing on-premise infrastructure and your existing on-premise security controls. So the first thing that we announced a couple of months ago is that VPC is in what we call general availability. So that means that it moved from being a beta product into being something which is generally available for all. So a quick note, actually, a side note, if you will, on what beta means at Amazon. So some of you may have noticed that some of our newer products, such as Simple Workflow and DynamoDB, shipped with a little beta tag in the corner. At Amazon, that means something very different to what you maybe expect it to mean. So at Amazon, when we say something is in beta, it does not mean that it's not operationally ready. Everything that we deploy and ship to customers, it meets our very high operational metrics and operational standards and are designed for production use. What that beta tag means is that the feature set isn't exactly where we want it. So we're going to continue to innovate by adding features, by taking feedback, and using that feedback to drive new features that customers want And that's what that beta tag means. So it doesn't mean that it's not ready for use, as some other people use it. At Amazon, we use it to mean it's not at what we might consider 1.0. It's a subset of features that we rolled out to customers as quickly as possible, but that has very, very high operational metrics and operational excellence that we've become to known for. So VPC moved from being beta to general availability with a wash of new features. And this is what I mean when I talk about going from beta to general available. It means rolling out the feature set that we originally envisaged when we started dreaming up VPC. So the first thing, VPC is now everywhere. It's available in all regions. So you can tie in and create these virtual private networks wherever you need it, in all regions, in all availability zones. It's gone multi-AZ, so you can deploy your private and public subnets into different availability zones, and you can create a single VPC that spans availability zones, either for disaster recovery or high availability services. And that looks something like this. So the big green box encapsulates everything. That's the region. Within that, we have these availability zones. If you're not familiar with our parlance, availability zones are collections of one or more data centers which are redundantly powered and redundantly connected. They're on separate fault lines and floodplains and all that sort of thing. And the idea is to create completely isolated environments, to create highly available applications, and to create highly durable storage. So S3, for example, stores data across availability zones and is able to reach 11 nines of data durability through that and the other mechanisms that we put in place. So using VPC, now that we have that in all regions, you can now deploy your applications in subnets within availability zones. So you see we have availability zone 1, 2, and 3, and within that we have a subnet which we've created using VPC, and inside that we've deployed the EC2 resources. So that may be an Oracle database, that could be a scale-out batch processing system, whatever it is. And we have associated to that VPC a collection of network access controls, both inbound and outbound, and they can talk to the virtual private network gateway that exists across the region. And so each of your availability zones, as long as you set the access controls correctly, can talk to that VPN gateway. And we also have an internet gateway. So you can't even talk to the outside internet without going through the internet gateway, which you have to specifically create and set access control lists around. Again, that's per region, and each of your availability zones, so long as you set up your settings correctly, can talk to the internet gateway. You can use the VPN gateway to talk back to your customer gateway in your existing data center, or as the name suggests, use the internet gateway to talk out to the internet, and maybe making web service calls or whatever else you want to do. We also added the ability to create elastic load balancers within the virtual private cloud. So you can now create ELB inside VPCs, again, to create large fault-tolerant elastic infrastructures. All of the services that you're used to using around EC2 and balancing loads across multiple instances for failover and scale are now available through ELB on VPC. And we added the ability to scale up EMR. So you can now spin up EMR clusters and job flows and launch elastic MapReduce flows inside your virtual private cloud. That means that you have better control over how your data moves. You can put access control limits around where that data moves to and from. You can even access data through EMR, which is housed on-premise. And we announced something which we call elastic network interfaces. This is similar to what we did with EBS. So EBS is our elastic block store, and what we tried to do with EBS was abstract away storage away from the actual instance. So you had your instance, which was just compute, and you had some abstraction of storage, which allowed you to do more interesting things with it. So in exactly the same way as EBS represents an encapsulated storage, so elastic network interfaces abstract away the network interface from your instance. So by default, you don't have to worry about this. But you can create network interfaces which are separate to your EC2 instance. That means you can do things like hot failover, an easy way of handling failover and high availability by having a single network interface which you can pump data into and swapping it between interfaces. It's also useful if you have MAC signed licensing and all those sort of things. You can move those between instances. So elastic network interface is a powerful tool for building out enterprise-grade networking. We also support VM import. This is a service which allows you to take your existing virtual machines in Xen, VMware, or Hyper-V format, and importing those up directly into EC2. We'll convert them into the EC2 native format, the Amazon machine image, and you can run those natively, the machine image, onto EC2. So this is great for extending your existing virtualized environment over the VPC network and spinning up identical replicas using the same virtual machines even in an elastic environment. It's also perfect for disaster recovery. You can take your encapsulated machine images that are running your existing enterprise applications, put them in cold storage, if you like, as an AMI by taking them through the VM import process. And then if you have some connectivity problem on site, you can just respin up your architecture and all your network topology inside the VPC, including all your VPN and everything else inside EC2 and recover quickly from that failure. The second thing I wanted to talk about, so that's VPC, the ability to create these network-isolated resources in EC2. But we also want to give customers an easier way of actually connecting to those resources. So VPC, as I say, allows you to extend your VPN. But there's still a reasonable amount of overhead in shuttling traffic and network administration over that. And customers told us they wanted an easier way of achieving connectivity with AWS. That's where Direct Connect came from. So Direct Connect offers customers a direct connection into our AWS regions. This basically allows you to say, well, I need a persistent connection up onto AWS, and I want to peer into the AWS regions. So you get consistent network performance, which is important because you no longer have to worry about going over the internet to get internet information up into your virtual private cloud. You can just do it over Direct Connect, get to the peering point, and then you're directly onto our network. You get full private connectivity. So using VPC and Direct Connect, you can have full end-to-end private connectivity from one end to of your data center all the way up to your isolated regions and resources on EC2. And it's still fully elastic. So you get to choose whether you want a 1 gig pipe or a 10 gig pipe. And you pay a little bit more if you want more, pay a little bit less if you only want 1 gig. And you can scale that up and down depending on your use case. So this is really useful if you want to reduce bandwidth costs. If you're pushing a lot of bandwidth in, because you are no longer talking to your ISP, you'll be talking direct to us. And we also have lower Direct Connect pricing for bandwidth when you're working with Direct Connect as opposed to our standard outbound bandwidth pricing costs. So it's a good way of reducing bandwidth costs. And here are all the peering points that we have currently. So we've been rolling these out pretty consistently month after month. We're now in Los Angeles, Ashburn, San Jose, Singapore, Tokyo, and there's one right here in London. So if you can get to these peering points, you can peer directly with our AWS regions. The third thing I want to talk about, an important aspect for enterprises, that's identity federation. And also interesting from a historical point of view about how far we've come in addressing the needs of enterprises and some of the things that we're thinking about. So some of you may be familiar with an Amazon service called IAM, Identity and Access Management. This allows you to create groups of users and provide API-level restrictions to those users. So much like you would in the Unix world, you could have a group of database administrators, have individual named accounts for database administrators, and then only allow those database administrators access to the RDS instances. Senior database administrators, perhaps, will be able to create and destroy instances. Other people can simply administer them, turn on and off multi-AZ. So you get very fine-grained individual API-level access and restrictions onto the AWS cloud, and you can set those out, issue credentials, and then revoke them as and when you want. You can do a ton of stuff with this, like multi-factor authentication. You can set up individual console access for each member of your team and that sort of thing. It's a very, very powerful tool, and it's at the heart of a lot of our enterprise services. Excuse me. So way back when we first started doing this, we were dealing primarily with smaller companies, startups. And so we initially offered just a master security credential per account. This is, I'm sure, how most of you are familiar with working with AWS. You have your public and private key, you have some certificates, but you have one of those for your whole account, right? So that's fine if you have a small number of accounts or if you have a small number of people that have access to them, but it's not that easy to revoke them, and it's obviously not a good fit if you have more complex organizations and more complex requirements for more people. So we moved from that to introducing IAM access that I mentioned earlier. So this allows you to create the users and the groups that I was talking about and allow these API policies related to users and groups, revoke those credentials at any time. So now, rather than just having all your credentials linked to an account, we've abstracted that away so that they're linked to users within that account. And that's what IAM provides. From there, recently we announced the security token service. So this is a lot like temporary access keys, which are limited by time. And you can set the time of those when they're issued, and you can issue as many of these as you like. So the security token service provides temporary access keys, which are again linked to IAM policies. So you get the same API level restrictions on each of these policies, but the token service issues them automatically, and they are time restricted. So if you like, these are the equivalent of a hotel door key. They're going to last only a certain amount of time when you actually need access to the hotel. You don't give everybody that needs access to the hotel the master key, which can get into the kitchens and all the rest of it. The security token service is like the door key that you issue when you check into the hotel. It has temporary access to a very restricted set, and those are still linked to your IAM policies. So identity federation takes advantage of this, of these security token service, and allows enterprise customers and their applications to access the AWS resources that they need for individual IAM users. So what does that look like? So you might consider a group of internal users that need to use an application. Let's say it's a reporting application. And they need to use that application in order to be able to, in using that application, sorry, they will generate data which eventually will get saved back to S3. Right? So you can imagine that we might have any number of employees. You don't want to have to issue all of them with IAM credentials when set up the policy in order to be able to allow them just to put some data into a particular folder in S3. That's a lot of overhead, particularly as most organizations, larger organizations, already have a canonical source of who can do what within the company. That's typically held within some sort of LDAP directory and brokered by an identity broker. So the process here becomes, how do we allow these employees and the applications they're using to have access to S3 in a secure way? So the first thing they do is they use the reporting application. That's number one. The reporting application goes off. It talks to the identity broker. The identity broker looks up the LDAP identity of that person and uses the AWS security token service to issue a temporary token which is linked to an IAM account of that user. The token service responds, passes that back to the broker. The broker then passes that back to the reporting application, and now it has the credentials that it needs to carry out the AWS task. So that may be an analysis run, that may be storing data in S3, as in that example. The reporting application on behalf of the employee can then take that data, store it in Amazon S3, and Amazon S3 at that point will look up to and validate that the user that's having it, has access actually is permitted to make that request based on the security token. So the security token will eventually expire. You can set the expiration date from 1 hour to 36 hours. And this allows you to basically federate the information within your LDAP directory across your enterprise applications all the way back to the Amazon resources. So the fourth thing I want to talk about, you may have read about this. This is the storage gateway, the AWS storage gateway. This, I apologize to say, requires a data center. So if you've already got a data center, this may be super useful for you. If you're already running 100% in the cloud, that's awesome. But if you're not, there'll be some useful things in here for you. So you will need a data center to take advantage of storage gateway. The storage gateway allows you to connect on-premise storage with AWS. So again, we're trying to allow enterprise customers to securely integrate their existing resources in terms of compute with VPC, and in terms of storage with the storage gateway, and in terms of identity with identity federation with the AWS resources. So the storage gateway allows you to connect on-premise storage with AWS storage. So it's a software appliance. We're actually shipping a software appliance as a VMware ESCi 4.1 virtual machine, which you spin up on-premise. You attach the storage to that virtual machine, and the software appliance can then do some smart stuff on your behalf. So it'll take on-premise data, and it'll back it up to S3 for you. So you get the durability, 11 nines of data durability. You get multi-AZ and fault tolerance, all the reliability that you're used to using with S3, and you can take your existing data and back it up directly into S3 automatically. The snapshots themselves of your local storage are stored as EBS snapshots, which is useful for a couple of reasons. Because you can recover and restore on-premise. So you can take those snapshots that are stored in S3, and if you have an internal failure or an internal disaster, you can recover from that and bring down the snapshots, remount them, and make them available to your company. So basically recover and restore, and you can test that. So it's a great disaster recovery plan. But you can also recover and restore on EC2. So you can take those exact same snapshots, and instead of just recovering them back onto your local disks, instantiate them as volumes on EC2 with EBS, connect up your compute, so you've got the actual virtual machines that you're running that you can import through VM import, and you've got the actual data that you were running backed up through the storage gateway onto EC2 as EBS volumes. So this is a perfect disaster recovery scenario. We charge $125 per month per gateway, so not that much. And this is what it actually looks like once you spin it all up. So you have your data center here over on your left-hand side. You have your application server. It has an iSCSI interface into the storage gateway. That has some local application storage, and hanging off that maybe some local disk or some SAN disks. It runs on top of the hypervisor, right? This is a virtual machine running on VMware. And then the storage gateway will take that data, back it up using the AWS Storage Gateway Service into S3 as encrypted volumes and encrypted volume snapshots. And then if you do need to, you can instantiate more compute and attach those as EBS volumes against the EC2 instance. So a full life cycle of disaster recovery there. We use SSL when the data is in transit, and we encrypt the snapshots using AES 256 when they're at rest in S3. Which brings me nicely on to the fifth thing that I was going to talk about. I promised I'd talk about security, and I don't want to disappoint you. So I want to talk a little bit about security and how Amazon approaches it. So this may be one of the most important slides that I show today. Amazon operates a shared responsibility model when it comes to security with our customers. So we share the responsibility of securing the infrastructure with our customers. So Amazon takes on this responsibility of securing basically the infrastructure layer. So that's everything from the foundations of our data center all the way up to the hypervisors of our virtual machines. That's on us, and we take that responsibility very seriously. But because we don't have visibility into what you're running on EC2, for example, everything beyond the hypervisor, so the operating system, the applications that sit on top of that, the data that's housed within those applications, it's our customer's responsibility to make sure that those are up to date and secure and meeting your own compliance and regulatory needs. So you need to make sure that your data is encrypted at rest if necessary and all those sort of things. It's your responsibility. We take responsibility for the underlying infrastructure. So on our side, we take requirement-based access very, very seriously. So nobody gets anywhere near the cages of our data centers without having a very, very good reason. Those reasons are audited both internally and externally by Ernst & Young. We have high levels of certification that certify how our internal processes around securing our infrastructure. So we're ISO 27001 compliant, and we're SAS 70 Type 2 compliant. And another what's new feature, we recently retired our SAS 70 Type 2 and rolled out the more transparent, higher level SOC 1, which conforms to these standards. So we're going to continue to roll out higher levels of certification as we get to it. Here are our control objectives. We are certified against all of these sort of things. So security organization, our internal chain of command, employee lifecycle, background checks, and that sort of thing, the logical and physical security of our infrastructure, secure data handling and environmental safeguards, so fire suppression systems, change management, incident handling, what we do when something goes wrong, and the data integrity checks and availability and redundancy that you're familiar with services such as S3. So that's what we're certified against. We have detailed logging in place for services such as S3, and customers can do their own logging at the application tier and push that back to S3. We are FISMA moderate compliant across our regions, and we're also able to host and meet the HIPAA regulations for personally identifiable health records. We're PCI DSS level 1 compliant. This is a payment processing standard. We're compliant to that at the infrastructure level. And this is a really good example of how we see the shared responsibility model. We undertake and are certified to level 1 for the PCI DSS standard. But our customers, if they want to process payments on top of that infrastructure, have to certify their application in addition to that. We have data access controls and network access controls that I've described, and also the sort of identity and access management controls, fine-grained API-level restrictions that you can control dynamically. And if you want to know more about that, you can read more in our white paper that's available in our security center, aws.amazon.com/security. We have a white paper which is an overview of our security processes, which goes into a bit more detail around some of the control objectives that I mentioned. And we also have a newish risk and compliance white paper, which is well worth a read. You can download them in PDFs, put them on your Kindle, and read them on the way to work. And with that, I'd like to round out with Q&A about anything that I've spoken about today, anything about AWS, and I'd welcome your feedback on any other services.
Hi.
Hi.
Could I ask, is the virtual private cloud accessible over IP version 6?
You know what? I don't know. Dob has an answer for you. Dob. The answer is not yet. Yes, sir.
I was confused about the pricing for the Direct Connect ports, because obviously it's priced per hour, but per hour of what? Because the ports is either up or down. So.
Right, so it's priced per hour of up, and then you pay for bandwidth in addition to that. Inbound transit is free, and outbound has lower Direct Connect pricing, because we can reduce the cost by being peered directly with you.
So you just make a request to have the port shut down, and then you stop.
Yeah, so you can do it in exactly the way you would spin up an instance. So you just say, I want a 1 gig port open now, and that's when we start charging you. And when you tear it down, that's when we stop.
Oh, I thought it was a manual process for requesting the port, though.
Oh, for the initial requesting, yes, but actually opening the connection.
Oh, I see. Right, once it's up.
That's per hour. Yeah, once it's up.
Okay.
Yeah, sorry. All right, we have time for one more. Yes, sir.
Someone else's hand went the wrong way.
Thank you. Don't start fighting over me. I've got another customer who sees cloud services as kind of the poor man's server who can't quite afford dedicated hosting, and they've got various. They're paying absolutely through their nose. One of the quotes they got was £5,000 a month for a system that was no single point of failure. How do you get it through to these people that this is actually a better option?
That's a good question. So I think it's about education, and it's about understanding the value that the cloud can provide. So more generally, I mean, we talk about things like elasticity. We talk about the importance, as Glenn was saying, of being able to have the capacity to be able to scale up and scale down in a very dynamic fashion. And we're working hard to make sure that we can do that in a cost-effective way. And again, Glenn talked about understanding the importance of things like reserved instances, understanding when and where to use Spot to drive the prices down, right? So there's this broad ecosystem of services that we're building out, which can offer much higher levels of dependability, reliability, and flexibility, and but whilst have a significant cost optimizations attached to them. So that's really the message that we talk about a lot with customers, and that's what I encourage you to do as well.
Thank you. Regarding uptime, I mean, can you offer them something? I mean, they're looking at Amazon services that aren't offering something contractually that they can get from another company.
Sure, so we have certain things in place around API availability, but we want to give our customers the tools to be able to build out the sort of services and features that meet their own requirements. So if you have very high requirements for availability...
This customer couldn't survive an hour downtime.
Yeah, okay, so you build out a service which can't survive an hour downtime, using the things like elasticity and fast failover.
And is that something they would need to use Amazon and someone else to be able to guarantee that?
Well, I mean, we have a great partner ecosystem, so a lot of them are here today, so I'd encourage you to talk to those guys about it. But it's really down to our customers and our partners to build out and understand their own customers' requirement and to be able to use these building blocks, these infrastructure building blocks, to be able to build out highly available services. Any more for any more? Yes, sir.
Just a quick question about the slides for today. I think you mentioned that they'd be available online.
Yes.
Just wanted to sort of prompt you to remind us.
Yes, they will be available online. I'll put them up on SlideShare, and we'll send an email around to all of you with the links to that. And I think we're recording some of this as well, so we'll try and make the videos as well. Claire's
wonderful.
That's good.
Thank you very much.
You are welcome. All right, so I'm going to close it out there. I just wanted to finish just really quickly with what's next. What's next is basically we're going to continue to listen to you guys. Everything that we do is driven by your feedback, and so we really appreciate you taking the time to learn about some of the things that we've done. But this is really day one for what we're going to be doing in the cloud space here at Amazon, and so we really want to hear your feedback about any of our services, any feature requests, any of your pain points, so that we can continue to build out these services to continue to remove those sharp edges from you guys using this infrastructure to build out really amazing services. So continue to send us our feedback. I thank you very much again for listening, and refreshments are available in the lobby. Thanks a lot, guys.